So all my resistances are going to be 5 ohms. Obviously, there's only one here, so 5 ohms. Okay, fine. The idea now is you can simply go ahead and calculate the current. If you check the current coming from the battery, there is only one resistor in its path. I is V over R. So I have calculated my current by doing V divided by R, 10 divided by 5, 2 amps. Now, what would happen to my total resistance if I added a resistor? Will my resistance increase or decrease? The current has to flow through both resistors now. I now have 2 resistors for the current to flow through. So that's harder for the current to go. My resistance will increase. Adding more resistors in series increases my resistance. That's why you have the rule, the resistors is R1 plus R2, because the total resistance has increased here. In this case, my resistance has increased. Over here, my resistance was 5 ohms. R was only 5 ohms. Over here, my R is not 5 ohms. It's 5 plus 5 is 10 ohms. Adding a resistor in series increased my resistance. How will that affect the current? Let's find out. V over R. Now, the current has to flow through both of them, so I must include them both. 10 divided by 10, which gives me 1 amp. My current has decreased 1 amp. So I had a single resistor. I calculated the current and the resistance. I doubled my resistance, doubling my resistance, and look, my current halved. My current became half. So the current is proportional to V over R. If I increase that to 20 volts, it will become 20 divided by 10. That will increase again. The current and voltage are directly proportional. The current and resistance are inversely proportional. That's fine, but now let's add a resistor to my standard resistor that I had. That was 5, wasn't it? It was 5. And then this was 10 volts. Now let's add a resistor in parallel. Now, adding resistance in parallel, let's see what happens. Now, the idea here is we have still got 10 volts. I still have 2 resistors, but I've set them up differently. The current now has a choice. You see a junction, you see a choice. The current can go to the first loop or the second loop, only through one resistor, not both. The current only needs to go through one resistor in its loop. So we know the rule for the resistance. I've mentioned it to you for the parallel. That rule is the R for the parallel is 1 over R plus 1 over R. 1 over R, 1 over R. And the little calculator trick is put them in -1 in a bracket. Another trick I mentioned to you is if you have 2 resistors that are identical, the total will always be half. 3 identical, the total will be a third. 4 identical, total will be 1/4. You just divide by the number of resistors. So without having to solve it, I can realize that the total resistance in this whole thing, my R actually is 2.5 ohms, half of 5. If you don't believe me, check yourself. 1 over 5 plus 1 over 5, that's 2 over 5, flip it, 5 over 2, 2.5. That's my resistance. Let's check the current. The current flowing through, I have the total voltage. I equals V over R, the whole circuit. I want the whole battery voltage, the whole circuit. So I will take V divided by R, 10 divided by 2.5. 10 divided by 2.5, of course, is 4. Well done. 4 amps. So that's I. Now, let's see what's happened now. One resistor alone, my current was 2 amps. Adding an extra resistor, my current reduced by this. But then adding it in parallel, I increased my current. So in parallel, adding resistors decreases my resistance, it dropped, but it increases my current, it gained. But the voltage is the same for both of them. This is where some people start to get confused now. In a simple parallel circuit, the voltage is the same, meaning I can go ahead and calculate the current going through each branch. I can kind of guess that it's going to be half and half because of the fact that the resistors are equal, but I can just double check. V over I equals, I've messed that up, let me try that again. I equals V over R1. I want to know specifically R1, this branch only, not the total current, just this branch. I know the voltage is 10. I know that is 5. That will give me 10 divided by 5. 10 divided by 5 is, of course, 2 amps. Doing the same thing over here, I2, this will be also V over R, 2 amps, 10 divided by 5. Now, does that make sense? This branch has 2 amps, this branch has 2 amps, and they join up. The total current was 4 amps. That's perfect. 2 plus 2 equals 4. 2 amps flowing here, 2 amps flowing here, and they join together, 4 amps in total. So that's how current flows in a simple parallel circuit. Let me just recap what I've just did one more time. I just had a single resistor. I put in some fake numbers. I put in 10 and 5. I calculated my current to be 2 amps. My resistance was 5. Over here, same thing, 10, and I added an extra resistor, 5 and 5. In series, the current passed through both of them. My resistance increased. So if my resistance increased, I can calculate my current again, V over R, and look at that, my current decreased. The current became 1 amp, doubling the resistance, halved my current. This is the rule over here for it, Ohm's law. Then I checked with parallel. Let's see what happens in parallel. I have my resistor, but now I have a choice. I have 2 parts. So what I did here was I added 2 resistors in parallel, 5 ohms, 5 ohms, found the total resistance to be 2.5, 2.5, calculated the new total current from the battery, which is connected to both resistors. That became 4 amps. Adding a resistor in parallel actually increased my current, decreased my resistance. We can check with fake numbers. And then I can go ahead and find the current through each branch specifically, 10 over 5, 10 over 5. And both were 2 and 2. 2 amps plus 2 amps passing through here equals to 4 amps. Next, you have something else. You have maybe something that looks like this. Having this, and then this, and I'll add a parallel separately. So let's just check this one out. Let's say I had 10 volts. And I'm not going to keep the numbers. No, I will keep the numbers. I'll keep them 5 and 5. Another question you could be asked is, what is the voltage across this resistor? And then what would happen to the voltage if I increased the resistance? That's the idea. Or if I increased this resistance, what would happen to the voltage? They are sharing the 10 volts from the battery. So this and this must share the voltage. So we can guess that this is going to be 5 volts and 5 volts because they're equal, but let's verify. First things first, in order for me to calculate the voltage, I need to do V equals IR. There's another way as well with the voltage divider, but I will stick with the simple Ohm's law. V equals IR. I haven't figured out I yet. Let's figure that out quickly. V over R. 10 volts divided by series. I must use the total resistance, 5 plus 5. 10 over 10 is 1 amp. So all I'm going to do is V equals IR. V equals I, which is 1, multiplied by R, which is 5. 1 times 5 happens to be 5 again. 5 volts. This is 5 volts. I can do the same for this one. Exactly the same thing. Take my voltmeter, stick it across this one, and double check. V equals IR equals 1 times 5. Same current as flowing. 5 volts. 5 volts, 5 volts. Does that make sense? 5 plus 5 equals 10. That makes sense. Now what would happen if I, let's say, increased this? Imagine I doubled this. Imagine I doubled that. So let's close that over. Let's close that over. I doubled that. So I'm going to start again. And let's just double check. You don't have to do this every time. I'm doing it so you can see the idea and the relationship between them. Now what I have done is I've increased this resistance to 10. This is 5. They're both still sharing 10 volts from the battery. I just need to figure out how much each one will have. So I have, just to write a note to myself, I have increased the resistance here. Let's see what happens to the values. First things first, my current will have to reduce. More resistance means less voltage. So I need to do this now. I need to do 10 volts divided by a total of 15 ohms. 10 over 15. Of course, if you know 10 over 15, if you're a wizard with maths like I am, that is 0.67. 0.67 amps. My current has decreased. All right. Voltage in total stayed the same. Now let's see what happens here. V equals IR, 0.67, and I'm going to multiply that by 5. 0.67, 0.67 times 5 is, of course, 3.35 volts. Now, I can find this by just subtracting 3.35 from 10, or I can just go ahead and calculate it again. 0.67, and I'm going to multiply that by 10, because it's 10 ohms, right? And 0.6, that's 6.7. All right, 6.7 volts. This plus this equals this. Thereabouts, I rounded, so this should have been 66666. So this plus this equals that. Perfect. So now we know. What happened though? Before we had 5 volts and 5 volts. Originally, we solved it, remember, we had 5 volts and we had 5 volts. Now look what's happened. This voltage reduced. This voltage increased. When I increased this resistor, this voltage increased. That makes sense because this now requires more energy to push the electrons through it. I need more voltage for the little electrons to pass through because the resistance became greater. Over here, the resistance stays the same, but unfortunately, because this one, all of the pi, this has only got 3 volts left for the electrons to go through with. So increasing this resistance increased the voltage, which unfortunately had to decrease the voltage here. From 5, it dropped to 3.3. From 5, this increased to 6.7. The total remained the same. Next, a question won't ask you so simply. A question will say, well, okay, then, what would happen if I added another resistor in parallel with this resistor? Now we're getting into ATS physics. This is another 5 ohm resistor. Now the question says, what will happen to the resistance, the current, the voltage? You need to figure it out. Now, let's think. Let's go back. Over here, we realize that adding a parallel resistance to the branch decreased the resistance. Having it in series, of course, will increase the resistance. So now what have I done? I have 2 halves. I have 2 separate parts. I'm going to cut it into 2. I added something here. This is the parallel section, and this is a series section. They're series with each other. Adding the resistor in parallel over here, what happened? I decreased my resistance according to what we just figured out. My resistance decreased, which means my voltage will decrease as well, I should say. There we go. Which means the other side, remember, they're sharing the 10 volts. If I'm losing less voltage here, I must use more voltage here. We can go ahead and figure it out. Let's try that now. Let's redo this question again, and I'm going to now set this up back to normal. This was 5, that was 5, but now I've added a 5 in parallel to one of the resistors. Let's go ahead and try to calculate everything again, and let's verify that what I have just said is true. Let's see. This is R just for this part, by the way, not the total R. Well, also will be the total. Anyway, let's figure it out. I is V total over R total. 10 divided by, well, I haven't figured out the total resistance yet. I know these two are parallel. I can go ahead and calculate it just like I did on page 9. I can go ahead and calculate it, or I can realize that parallel 5, the total will become half. That's 2.5 ohms, these two. 1 over R, 1 over R. Verify yourself if you don't believe me. Next, this is also still 5. Total resistance in series, I just simply add them. I will do 2.5 plus 5. So I, like I said, is V over R. That's supposed to be a 10, by the way. V over R, 10 over the total resistance, 7.5. Now, if I do 10 divided by 7.5, what do we get? 10 divided by 7.5. I get 1.3. 1.33 amps. So my current is higher than before. Very good. Now, I know my current is 1.33. I can find the voltages across both of them. If this is scaring you, let's just check this one. V equals IR. 1.33 multiplied by 5. This will be the voltage required for this resistor. 1.33 times 5 is, of course, 6.65. 6.65 volts. Look what happened now. I added a resistor in series. I decreased the resistance, and I can see that my voltage will also decrease. I can subtract 10 and 6.65 to get my voltage, or I can calculate it again. Same thing I'm going to do. I, which is of course 1.33, multiply by the total resistance in this path from between here and here, between these two junctions. We have these two, and the total is 2.5. 2.5. 1.33 times 2.5 will of course become 3.35 or 3.33 really. 3.33 volts, which makes sense. This plus this equals this. What happened now? Let's just verify. Adding the resistor in parallel decreased the resistance, decreased my voltage for this section, which means this has more voltage to play with, 6.65. The total still adds up to 10. The total voltage in the circuit is still 10 volts. What do you think?
Mister, but here you calculated the total resistance. What if I calculated for each? Is it going to be different?
Well, what do you mean by, so you want to find the voltage across here and then here? Is that what you mean?
Yes.
Yeah, that will be incorrect, unfortunately, because if you remember, voltage in parallel is the same for the resistors. I don't have a separate voltage for this one and a separate voltage for this one. It's not true. Both of these voltages are equal to each other, which means I must include both resistances in my voltage formula. So for the left-hand side, for this part of the formula, I know that the voltage should be equal. 3.3, 3.3, because they're parallel. If they have the same voltage, I need to know the total resistance, which in this case is 2.5. In fact, I cannot do it separately. So that's a general idea of what you can expect from a series and parallel circuit. Once you've figured out the voltage here, you can simply use this number to calculate the current flowing through this path. I can find I flowing through both of the paths now. Obviously, current does not flow through a voltmeter. That blocks the current from flowing through it. It's just measuring the energy. I can use this number now to find the current in R1, for example, and R2, for example. I can find it. V over R1. V, which is 3.3, divide that by R1, which I know is 5. 3.3 divided by 5. I need to know this voltage before I go ahead. So this is no longer going to state 5. This is actually now going to state 3.3 volts. Very nice. I can do that. Check that with your calculator. 3.33, divide that by 5, and you should get, not 5, yes, 5. You should get 0.67 amps. And I can check over here as well, do the same thing, or I can just add the two together to get my current. If you remember, my total current was 1.33. If you remember that, we solved it. So I can subtract 1.33 and 0.67, or I can just calculate it. Let's double check. V over R2 now. 3.33. I'm going to divide that now. Voltage divided by this resistor at the top, which is of course 5. I don't know why I did it again. The number is exactly the same, 0.67 amps. This plus this equals this. So the current literally split in half. Half of it went this way, and half of it went through this resistor. Is that okay with the current? And it meets here,
Yes.
and it meets here, and then all 1.33 continues on. 1.33. That's the stuff for circuits that you're required to know for your end of term exam.